these are the problems that you got Thursday in class and you worked on there, and then I had you working on them Friday while you were at home. So I thought that today I would go through and sort of explain how we come up with the answers to these and work through them. So feel free as I work through these to pause the video if you need to make sure that you kind of understand how we're getting the answers to these problems. So first of all, I want to kind of go through the top and mention some of the stuff in review. So you remember that the density of a substance is a measure of how much mass is packed into a certain volume of the substance. So what that means basically is that substances that have a high density are those that have molecules that are packed together really tightly, while substances that have a low density have fewer molecules packed into the same amount of space. And you do remember from what we talked about the other day that density is found by dividing mass by volume. So density equals mass divided volume, or density equals love. So the size or the shape doesn't matter of the substance. So if it is a pure substance, the density will always be the same no matter how much of that you have. For example, water is always going to have a density of 1 gram per cubic centimeter, and that's going to be important later in one of the problems that you do. So let's jump in now and start working with these problems that you are given. So if you remember in class of the day, I told you to circle in the problem what it is that you're trying to find, underline the information that is given to you, write down the formula, and then plug it in. So as we read question number 1, it says, what is the density of carbon dioxide gas? So right off the bat, what is density? This is what we're trying to find. Let's write the formula. If 0.196 grams, which is mass, occupies a volume of 100 milliliters, which is volume. We have the information. We just need to plug it into the formula. So it is 0.196 grams divided by 100 milliliters. And you know from math that anytime you divide by 100, you just move your decimal place to the left the number of zeros. So our answer becomes 0.00196 grams per milliliter. For the next problem, it says that 25 milliliters, which is volume, of a liquid has a mass of 27 grams, which is mass. What is the density, this is what we want to find, of the substance? So if density equals mass divided by volume, plug in our numbers. The mass is 27 grams. The volume is 27 milliliters. 27 divided by 27 is 1 gram per milliliter. In question B, it says, what is this substance? So if we go up here and look, remember that water is always 1 gram per cubic centimeter. Cubic centimeter is the same thing as a milliliter. So this substance is water. Question number 3. An irregularly shaped stone was lowered into a graduated cylinder holding 2 mils of water. The height of the water rose to 7 mils. If the mass of the stone was 25 grams, what was its density? Again, so it's asking us for density. Let's go ahead and put our formula down. Density equals mass divided by volume. 25 grams is mass. But we don't know the volume directly. We're going to have to figure it out. So it tells us that the graduated cylinder had 2 mils of water. And then once we put the stone in, the water rose to 7 milliliters of water. So it rose by how many milliliters? If it went from 2 up to 7, it rose by how much? It rose by 5 milliliters. So the volume of the stone is 5 milliliters. So now we can plug in our formula, 25 grams divided by, 5 milliliters. "25 grams divided by 5 milliliters." So the density will be 25 divided by 5 grams per milliliter. Question number 4. A 10 cubic centimeter sample of copper has a mass of 89.6 grams. What is the density of copper? I want to know density, so I write density equals mass divided by volume. I know that 89.6 is the mass, 10 cubic centimeters is the volume. Plug into the formula, 89.6 grams divided by 10 cubic centimeters. When we divide by 10, we just move the decimal place to the left, the number of zeros, which is 1. So our answer becomes 8.96 grams per cubic centimeter. In this next problem, we begin to deal with two different substances, and it's wanting us to compare those two substances. So let's look at, it says 5 mils of ethanol has a mass of 3.9 grams, and 5 mils of benzene has a mass of 4.4 grams. What's the density of each liquid? So let's separate these out. Let's look at ethanol first. And we know that this is the volume of the ethanol, and this is the mass of the ethanol. For benzene, this is the volume, and this is the mass. So it wants us to find the density. Again, density equals mass divided by volume. We know the mass, we know the volume of both of these, so we should be able to calculate their densities. So let's start with the ethanol. The mass is 3.9 grams. The volume is 5 milliliters. 3.9 divided by 5 is 0.78 grams per milliliter. For the benzene, it is 4.4 grams divided by 5 milliliters. 4.4 divided by 5 is 0.88 grams per milliliter. It asks us which one of these would float on top of water and which one would sink on water. So remember, back up here, water is 1 gram per cubic centimeter. So anything greater than 1 will sink, anything less than 1 will float. Both of these are less than 1, so both would float on top of water. Neither would sink. Now, in full disclosure, there was an error in this problem, and I'm not sure where it's at. I know that 0.88 is the density of benzene, but the density of ethanol is actually something like 0.00078 grams per milliliter. So within the problem itself, there was a misplaced decimal. So if you're going and looking at the densities of these liquids, you're going to find a different number. So there is an error in this problem. But the important thing is that we're doing the math and we're going through the process. All right, on to question number 6. Same thing, we're looking at two different objects and we're comparing the densities. So it says a small sample of iron has the dimensions of 2 by 3 by 2. and has a mass of 94 grams. So 94 grams is going to be our mass. We don't know the volume yet. We're going to have to do length times width times height to find the volume of this sample of iron. So 2 times 3 is 6, times 2 is 12, so the volume is 12 cubic centimeters. We look at the larger sample, and it has dimensions of 4 by 6 by 4 and a mass of 752 grams. So 4 by 6 by 4 would be 96 cubic centimeters. We'll come back and write that down in a second. I don't want to confuse you with where I place it. So let's look at our densities. So the density of the small sample is going to be 94 grams divided by 12 cubic centimeters, and 94 divided by 12 is 7.83 grams per cubic centimeter. The larger sample is going to be 752 grams divided by 96 cubic centimeters. And again, that 96 came from the 4 times 6 times 4 to get the volume. So 752 divided by 96 is 7.83 grams per cubic centimeter. So what this is asking is, we have two different samples of iron that are two different sizes. We calculate their densities and we get 7.83 as the answer for both of those. And then it asks us to explain the answer. So the answer is, back up here again, is that the size, the shape of a sample doesn't matter. The density is always the same. So it doesn't matter that we have two different sizes of iron. Density is a physical property, and density is always going to be the same no matter how much of it you have. Okay, so now we're to the last problem. And again, we're comparing two different things. This time it says that silver has a density of 10.5 grams per cubic centimeter, and gold has a density of 19.3 grams per cubic centimeter. Which would have the greater mass? 5 cubic centimeters, which is volume of silver, or 5 cubic centimeters, which is volume of gold. So this time it's asking us to find the mass. So it is saying which would have the greater mass. So if we do our density triangle, let me just draw it right here. So remember the density triangle. It's M, D, V. We're going to cover up what we're trying to find, which is mass. And what's left is D times V for our formula. So the formula that we're going to follow through is mass equals density times volume for these two objects. So for silver, we're going to take 10.5 grams times 5 cubic centimeters. And we find that 10.5 times 5 is 52.5 grams. And now for the gold, we see that 19.3 grams per cubic centimeter times 5 cubic centimeters. 19.3 times 5 is going to be 96 0.5 grams. Sorry, I forgot to write grams per cubic centimeter there so that they can cross out as we're doing our math to get grams. All right, so the sample of silver has a mass of 52.5 grams. Sample of gold is 96.5 grams. So hopefully you did okay on this worksheet. If you remembered to just constantly write your formula down, circle what you're looking for, underline what is given, and label them as mass or volume or density, plug them into the formula. Use your density triangle when you need to. And there you go. Enjoy the rest of your day.